Hello dear friends, welcome to another video of the Never Do Through the GUI, what you can do through the CLI channel. I am Vangelis Prokopiou and today you are watching Web API benchmarking PHP Laravel vs Rust actixweb. Sorry for my throat, I am a little bit, but anyway, this video came up after talking to a friend of mine, let's say, somebody that we talked about Web API's performance and scaling and problems with interpreted language and in particular with PHP and the Laravel framework. So I decided to create this benchmark, both for me to demonstrate the difference between these two technologies, both for me to see myself what the difference is, what the actual difference is, but also to provide some help and some information on the subject to this friend of mine. So two reasons for creating this video, and hopefully it will be beneficial to you too. So let's get into the video. I have as I said, two APIs. The one is this. It is a Laravel API, and I changed some stuff in order to make it a little bit more lightweight. I don't want code that is not needed to run during the test. So in essence, I'm using this user PHP class, and what I do is here in the user controller, I just create 100 users here, and I return them as a JSON array. So pretty simple stuff. And also, as I said, I disabled, this is what we will run. We will run in Docker. I also disabled the xdebug mode, so we have no xdebug installed. And generally, I disabled, as I said, code, just like here, that maybe slows the performance of this framework down. So we will be able to access this API here at this URL, and now of course it is not accessible because the Docker containers do not run. And this is what we will do. This is the other project and the instructions. Let's start with the Laravel API and let's build it. So we will come here and we will say that we want to build it. It's built and it started running. Docker PS, we have the containers running. So if we come back here and we refresh, you will see that we have our output. We have these users with ID 1. We started ID 1, first name 1, last name 1, etc. And we come down here with the last user with the ID of 100. And first name 100, last name 100, and framework Laravel. So indeed it is working as expected. We are hitting these users handler, and we are getting back our users. So since the API is working, I will start benchmarking the API. But before I do that, I want to drop into the container and run an HTOP on it in order to see live the performance. So we will say Docker PS sorry, let me rerun it. So PHP, the container is PHP, so we'll say Docker exec. I will zoom in after I run the command. Docker exec it. We want to run it on PHP container, and what we want to run is the bash command. So now we are in the container, so let's apt install htop for starters. We are within the container and let's run htop. So this is our current status within the container. This is the CPU usage and everything. I will have this full screen and we will use the other terminal. Where is the other terminal? Here it is. Okay. Let me clear this. We are within the container here in the htop command, and this is our normal host terminal where we will start benchmarking. So let me get the command, and the command is this. This is our command. We will use the without keep alive option, so we want to stress the API as much as possible. And in essence, what we are running is the Apache benchmark tool. We will run 50,000 requests and 1,000 of them will be concurrent. So this is our setup. Let's start running and let's see what happens. The benchmarking started. As you can see, all our CPUs are maxed out. We will wait for it. I'm reminding again, currently we are benchmarking the PHP Laravel API, and we just hit an endpoint and we get some users back. The users are created on the fly. It's an array of the user class, and it is returned to the caller. As you can see, still inside the container, everything is maxed out regarding the CPU usage. And the memory usage, I can't understand myself here exactly the memory usage. If indeed this is it, the memory usage seems consistent, which is a good thing. We are at 30,000 requests, 35. Of course, this is not the ideal setup to run benchmarks because we are both running the benchmarking tool and our server within the same host. But it will provide some information which is indeed insightful, I think. So let's wait for it. 5,000 to go. And we're about to end since the CPU usage, as you saw, dropped down. And waiting for the final aggregation of the data. And it timed out, and we did not get the information. Okay, let me retry then. I will kill the h stop altogether. So we will quit and we will exit from the container, and let's try rerunning. Let me check the system like this. These are the resources of the host, the state of the host machine. Let's see the CPU usage. As you can see, again, it's maxed out. And as you can see, I have 8 CPUs. My current machine has 8 CPUs, virtual 16 CPUs. Yes, and indeed the memory seems quite stable, which is good again. This memory, of course, does not correspond to the memory usage of the container, because I have 2 IDs open which take too much memory. So I don't know exactly how much memory the container is currently using. But the CPU usage, as we saw, was maxed out during this whole process, and it is maxed out again. So let's wait this time and see if we get the final data aggregation. Sorry for the delay, but I wanted to really flood the server with requests in order to have enough data and see an outcome that would be beneficial. Because if I just run 5,000 requests or 1,000 requests, as you can understand, the stress does not accumulate to the server. The more requests you perform, the more stress you get to the server, which accumulates. And now the requests are done again. Let's see if we manage to get the final aggregation of the data. Currently, due to the fact that I'm also running the recording application, maybe this had a severe, yes, it had a severe impact. It seems that we cannot do what we want. I will lower this thing. Let's make this I will try to pause the video and rerun it and see if I got a final result. So I'm pausing the video. Okay, I am back. Indeed, pausing the video recording helped the machine to perform the aggregation and provide us with the data after performing the 50,000 requests. So we have the data here. we will not look into it currently. We will benchmark our Rust API too, and then we will make a comparison. So we are done with this terminal. I will keep it open, of course. Let me kind of minimize it. And we have the data. Let's keep it here. So here we are within the Rust API. First of all, we will kill all the containers. So our previous API will not work anymore. So we don't have any stress from there. And this is where we will access the new API. So we are in Rust. So let's build this. Build it. Let's build the Rust API. I'm pausing again because to spare you a little bit of the building time, because Rust is a little bit slow to build the project. You know the reasons. So I'm pausing, and as soon as the API is up and running, I will get back to you. Okay, it finished. Let's check. Docker ps. Yes, we have our Rust API according to the Docker command. Let's see if we have a result here. Yes, we have a result. We have our users again, the user with ID 1, and if you check down here, the last one is user with ID 100. So we have exactly the same setup, same fields, ID, age, first name, last name, and framework. Same amount of data per request. And now it is time to start benchmarking this API, the Rust API. So let me prepare the command. Again, we will use the same amount of requests, the same concurrent requests. And let me bring the system monitor here too. I will not drop into the container to check with hstop. We will check only through this resources panel. So I think we are ready. Let me start benchmarking. And we are done. The Rust API benchmarking finished. This is the spike that we got for it in order to perform the 50,000 requests. So I'm closing this. And now it's time to start comparing our results. So let's come here. Let's start from here. Document path, document length, concurrency level the same, time taken for tests 163 seconds for the Laravel web API, 3 seconds, 0.2 for the Rust API. 163 seconds, 3 seconds. Completed requests 50,000, the same here. Failed requests, we have 339 requests that failed here for various reasons. Failed requests 0. Total transferred bytes, we have the bytes. Requests per second, we have 305 requests per second. This is the average requests per second. And for the Rust API, we have 15,593 requests per second, as you can see. 300 requests, 15,000 requests. 15 0.5 thousand requests. Time per request 3.2 seconds. This is in thousands and we are talking about milliseconds. So time per request is 3.2 seconds, as you can see. Time per request for the Rust API is 0 seconds and 64 milliseconds. So 3.2 seconds, 64 milliseconds. Transfer rate, we have 2,800 kilobytes per second, and here we have 1,056,664 kilobytes per second. I'm not going further into the numbers. I think you can see the difference, which is huge and it is obvious. So let's come here and see these things. We have connect time. I don't know how to interpret this. The processing, we have again, I don't know exactly how these are measured, but if I'm not mistaken, it says that we had 2 seconds processing. This is the medium, and here we have 4 microseconds. Again, I don't know exactly how they map this map and what they refer to, but as you can see, again, we have huge differences across the board. If you are interested, you can check the documentation of AB and check exactly what each one does, each one means. And here we come to percentage of the requests served within a certain time. So we are calculating in microseconds the time that the requests needed to complete. As you can see, 50% of the time we needed 2.1 seconds here, and in Rust 50% of the time we needed 5 milliseconds. And we have all these numbers, the percentages, etc. And this is the longest request, as it says here. And you can see that the longest request took 106 seconds. And for Rust, it took 3 seconds. So the numbers are, there are huge differences, not small differences, huge differences. And regarding the scaling, I think it is very obvious what Rust can do for you. Of course, within this video, I'm not hitting any database. We don't have this overhead. I'm just comparing the raw output and the raw performance of the two tools, PHP Laravel and Rust with actixweb. So imagine what potential Rust provides you for scaling your application if you have a very a heavy intensive application with too much traffic. And now also imagine your setup with multiple backends serving your application through Docker, etc. And just the raw potential that this can provide you when you need to scale. This is the point that I'm stressing. If your application is well served by PHP or by Python or whatever, and you have no problems, you can continue using that tool. But if you are into scaling and you have problems, Rust is a very useful tool, as you can understand. This was the video. I hope that the information is useful to you. If you have further questions, don't hesitate to reach out and ask through the comments or even through email. You can search and find my email. And that's it. As I said, thank you for watching and have a great day.